I'm Bob Johannes. The purpose of this tape is to provide an insight into the construction of competition free flight model aircraft. The particular type models that we're concerned with at this time are AMA gas competition. Before we get into the construction techniques involved, however, let's take a look at a typical state-of-the-art AMA gas competition aircraft, and that'll give us an insight into some of the construction techniques and considerations that we use during the actual building of the flight system. This is a typical airplane. You'll notice that it has a rather high aspect ratio wing and a rather long, slender tail boom. The primary consideration, in my mind, in building these aircraft is to make sure that they are as light as possible, but yet stiff as possible. The reason I didn't say strong as possible is because I think that most any kind of reasonable structure would be strong enough. However, we must go to rather significant lengths in order to ensure the stiffness that are required of these models. Stiffness is required because during the power portion of the flight, the models are traveling at very high speeds and consequently could distort the structure. Let's take a look at some of the components that are incorporated into one of these aircraft. The first one is a very high performance engine. This happens to be a Nelson 15, which is world class in FAI competition, using a fiberglass propeller wherein the fibers run the full length of the propeller blade, and the fibers in this orientation are required in order to ensure safety. A wooden or plastic propeller on these engines would be torn apart because they turn at very high RPMs, RPMs in excess of 30,000. The engine fuel is provided by a pressurized fuel system wherein the fuel is forced into a rubber bulb under pressure. Then the natural contraction characteristics of the rubber bulb force the fuel into the engine under pressure. All of this is controlled by a multifunction timer. This is a C-Lig timer which provides 4 functions. It shuts off the engine, it provides a rudder trim change, an elevator trim change, and then dethermalization at the end of the flight, or DT. So with that, let's take a look at some of the specific construction techniques that are required to build such a model. The first thing that we'll build on the airplane is the wing. I usually build the wing and tail first to completion, I mean through covering, because the finished wing and tail are required to help locate the pylon in the fuselage so that the center of gravity is in the correct place without having to add weight. And if you recall in the introduction, we talked about maintaining minimum possible weight. So, building the wing, the first thing we'll do is copy the rib pattern off of the plans. So to do that, a plain piece of typing paper with carbon paper, slide that underneath the plans, and then use a straight edge and a little freehand as necessary to draw the wing rib pattern. Okay, that takes care of the flat bottom and the leading edge. And now for the curved part, I'll just do a freehand because we can smooth it out once we cut it and sand it. So we'll just draw the top curve of the airfoil with short pencil strokes by freehand, following the line of the pattern. Alright, that gives us the pattern on the typing paper. Okay, now we've got the rib pattern, and we need to put it on some material so that we can make a template to use in cutting out the individual ribs. I use 16th plywood usually, but you can use thin aluminum or even balsa if you're very careful. In order to put the pattern onto the plywood, we'll use the 3M 77 spray adhesive, and you'll find that I use this quite extensively throughout the entire construction of the model. But it's a very useful product. So now we'll put a light coat of it on the back of this pattern. That's all it takes. Doesn't take much, just a light coat. And then we'll put the pattern on the plywood. And then we'll go over to the bandsaw and saw it out. Now that we've got the rib pattern cut out, it's time to cut out the ribs. And the way I do it is I cut them out one at a time using the template as a guide and a knife. The wood that I've selected in this case is 5.5 pound sea grain 1/16 sheet. I use sea grain almost exclusively in the construction of models, primarily because it is the stiffest cut of wood that is available. The 5.5 pound stock is, again, in an effort to keep the airplane light. It provides quite adequate strength, but lightweight wood like this is not wood that is readily available at the hobby shop. It normally has to be special ordered from a place like Lone Star, wherein they will indeed select the wood by weight and grain for you. So, let's cut out a couple of ribs. A lot of modelers like to use stacking techniques to cut ribs, wherein they cut up a bunch of blanks and then sand or cut all the ribs at the same time. I don't do that because if you don't try to cut the spar notches in the ribs while you're cutting them using the template, you can cut out the rib just about as quickly as you can cut out a blank. Now, I do take the time to cut the spar notches in one rib, and that rib then will be used as a guide to locate and cut the spar notches to precisely fit the spars that will be used in the wing. Now that we have all the ribs cut out, we can stack them up in preparation to cutting out the spar notches to give a precise fit on the spars that we're going to use in the wing construction. The way I stack them is to use a combination square, put the ribs up against the square, get them all squared up and vertical, and then insert pins to hold the stack together. And you'll note there is the one rib with the spar notch locations included on the top to be used as a guide. The next step is then to prepare the actual spars and leading and trailing edges that we're going to use in constructing the wing. I have already done that, and I'd like to point out the significance of these spars. They are what you might consider to be somewhat smaller than you would expect for a wing of the size airplane that we're going to be building. These spars are 3/16 square, but they are augmented with 7/1000 carbon fiber, which significantly increases the strength of the particular spar. The way these were made is to take some wax paper and a straight edge using the C77, a light coat on the bench, spread out the wax paper, another light coat, and stick down a metal straight edge. The spar is then stuck down to the table, lined up with the straight edge. The carbon fiber strip is then given a light coat of 3M spray, and that is adhered to the spar. Then it is glued permanently with Plastic CA glue. Now that we've talked about how to augment the strength of the spars with carbon fiber, it might be useful to talk about spar design a little bit. I think it's fairly common knowledge that the most efficient spar is the classic I-beam structure, wherein you have a strong cap on the top and the bottom connected with a web through the center. Now, this approach has been used in a lot of model airplanes, but it has a couple of drawbacks. First of all, this web is difficult to cut precisely so that you get a good fit, and the adhesive joint here is difficult to achieve a good strong glue joint, because you're gluing end grain balsa to a flat grain spar cap. So what I've selected to use is a different type of spar, wherein I use square spar caps, top and bottom. Then I augment the spar with carbon fiber on one face. Then I put the vertical web on the outside of that. Now what that does is it allows me to have a large gluing area for the vertical grain web. It traps the carbon fiber between the spar and the web itself, which tends to keep the carbon fiber from buckling, which is important consideration. And these spars are only slightly less efficient, theoretically, than the classic I-beam. So this is the type spar that I use in the construction of all my wings. All right, now it's time to cut the spar notches in the stack of wing ribs that we have. I use a piece of 2x4 that I've faced off on the disc sander so that the face is perpendicular, and I use that to make sure that the stack of ribs is not leaning one way or another when I cut them. That way I get the same depth spar cut in every rib throughout the whole stack. So I don't know how the sound is going to come through with the saw running, but we'll give it a shot here. Okay. Now we'll check the fit of the spar into that notch. And it's a little bit tight, so we'll take just another hair off of it. Okay, it fits fine now, but it needs to be a little bit deeper, so we'll deepen the slot just a little bit. Now that's a nice fit. Okay, the next step then will be to taper the trailing edge. What I've done here is I've cut a strip of wood out of a 3x36 sheet. In this case, the trailing edge is 1/4 by 1 inch. And I want to put a taper on it, leaving about a 1/16 of an inch thickness at the narrow end of the trailing edge. Now this can be done by properly positioning the rip fence and in combination with the tilt of the saw table. And by getting them in there properly, we can just run it through and we'll strip off the trailing edge. And a few strokes of the sanding block, sand away the saw marks, and we've got a tapered trailing edge. For those of you who may not have access to a bandsaw to cut out trailing edges, a convenient way of doing it is, again, put a light coat of spray cement on the edge of the workbench, stick down the blank that you've cut out from the piece of wood. It's the right characteristics that you want in terms of weight and grain, and then carefully plane it down on an angle so you get the right taper, and then finish it off with sanding. It's not a difficult process. It's just a little more time consuming than sawing it out on a bandsaw. Always try to leave about a 1/16 of an inch thickness at the extreme trailing edge. Another thing about doing it this way is you put a little static charge on the curlicues, and they want to stick to everything. So I'll go ahead and finish it up, and then we'll be ready to use that piece. Now that we've got all the wing ribs, the spars, the trailing edge, and everything cut and ready to go, it's time to start laying the wing out. I did want to mention a little trick that I've used successfully when drawing the wing plan. That is, you'll notice that this is half of the wing. When I drew it out on this brown wrapping paper, I put carbon paper underneath it with the face up, such that I now then have the layout plan for the left wing identical to the right wing on the back side of the paper. So we'll actually build the wing essentially in one piece, but starting with the right tip, finishing that, building the right main panel onto the right tip, then building the left tip, then building the left main panel between the left tip and the right half of the wing. I do it that way to preclude any possibility of misalignment at the dihedral joints. So the first thing we do is take the spray cement and spray a light coat on the workbench to stick the plans down. I use this piece of cardboard as a spray deflector to catch the overspray. This spray technique is not original with me. Actually, I discovered it while watching one of the Satellite City tapes on how to use their product. So now we've got the plans stuck down. We need to put a little wax paper on top of the plans. Again, putting a light spray. All right, now we're ready to start laying the component pieces down on the plan. Okay, the first step then in laying out the components to the wingtip is to take the trailing edge, which I have tapered, and I have put half the dihedral angle in it at this point, and I'll put the other half on the joining trailing edge from the main panel, and that way I get a nice precise joint, which is good and strong. But also, in the interest of strength, we want to set the ribs back into the trailing edge stock a little bit. And to do that, we need to mark the rib location and then go over to the bandsaw and cut some notches in the leading edge of the trailing edge to accept the aft tip of the rib. Okay, now we're ready to lay out the pieces and start the assembly of the wing. As I mentioned, I've prepared the trailing edge with the bevel at the dihedral joint. I've also done the same thing to the leading edge and to the bottom spar. So we're taking spray another light coat of the spray cement onto the wax paper. And then position the components we just talked about. You'll notice that this spray technique does not require the use of any pins, so there's no problem with poking holes in the wood. And actually you could build on a piece of glass if you wanted to. And what I'm doing is I'm lining up the bevels with the rib mark on the plans, and sticking down the bottom spar. You may notice that these tip spars do not have the carbon fiber augmentation. That's because there's not near as much stress put on the tip, and you don't need to have that extra strength. Now, to position the rib, I need to move the leading edge in just slightly. And we need to trim a little bit off the back end. A little more. And then I use a 10-degree angle guide to get the slope of the rib properly. The actual angle at the tip dihedral joint here, or polyhedral joint, is 20 degrees. Half of it built into the tip, the other half built into the main panel. So 10 degrees. Everything is positioned. And we can hit it with the instant CA. Okay, the installation of the rest of the ribs will follow the same pattern, and we'll come back once all the other ribs are in place. Now, as you can see, we have all of the main ribs in place, and I've added the top spar. Now it's time to check, since this is a tapered rib planform, tapered in thickness as well as planform, I should say. We want to make sure that it's a nice straight line across the tops of all the ribs, and you can do that with just putting a straight edge on there and just taking a look at the ribs to see if it touches all of them. If you would find one that was high, you'd have to sand it down, or a low one, you could augment it with a piece of thin 16th balsa on top and then sand it to contour. The next step is to add the diagonal ribs in the bays and the gussets along the trailing edge. Well, we've now got 3 of the 4 diagonal ribs put in, and I thought I might just show you how I go about cutting the angles. Actually, I sand them on this handy-dandy battery-powered disc sander that it was in one of the magazines recently on how to build it. It's really great because it does give you an opportunity to make precision joints, and you've got it right here on the workbench with you. So let's see, we want to put an angle on that. Yeah, let's see how that fits. Yeah, too steep an angle. This is just a cut and try. After you've done a few of them, you get so that your eye can see the correct angle. Pretty close. I'm still working on it. Okay, that looks like about right. Now we'll take a block sander and put a 90-degree corner on the back where it fits against the trailing edge and the tip rib in this case. Sand off a little more. And a nice snug fit. Push it down in there and hit it with the thin CA. Now you might notice that these ribs are not to contour. In other words, they're just oversized blanks. And I just cut them out roughly like that, fit them in place. Then I sand them down to profile, and this is a technique that I found to be quite useful, and one that I really don't know how widely known it is. But when you're sanding like this, we want to sand down to the profile of the fore and aft ribs, but we don't want to undercut the fore and aft ribs either. So we have to make sure that when we sand, that we know when we're down to the right contour. Well, one way to do that is to take the thin CA glue and run a little bit of a bead right along the top of the fore and aft ribs, hit it with a little hardener, and when that hardens, then you've got a hard surface against which you can sand. And so we'll then use a sanding bar and then just work those diagonal ribs down into the correct contour. And if you look at the light, you can see when you start touching the hardened surface of the straight ribs. Now, I'm not quite down to contour, but I think you understand the process. So the next thing to do is we will add diagonal ribs in front of the spar, between the spar and the leading edge also. And that will tremendously stiffen this, the entire wing tip. You might notice that there are no notches in the tip ribs for the turbulator spars, except for this root rib, if you will. And this is one of the ones that we cut the notches on with the bandsaw earlier. I've made a little tool that I use to cut these notches in these tapered spars as well as the diagonal spars, which is nothing more than in this case, a piece of 3/32 balsa with a piece of a razor blade glued on each side and a notch cut out of the corner of the balsa for the desired spar depth. In this case, the notch is 3/16 of an inch deep, and on the other end we have one set up to cut notches of 3/32 square. So the way you use this then is to take a straight edge, lay it on the wing, and determine the position of your spar, and then slice the spar notch into the rib and then knock the piece out with the shoulder. So when we come back, I will have added the leading edge diagonal ribs, the vertical webbing between the spars, and we'll have sanded and shaped the leading edge. I came back a little sooner than I said I would, because it occurred to me that you might be interested in how I go about fitting in the vertical grain spar web. In this case, I've used 1/16 sheet with the grain running vertically for this first bay, but then I'm using 1/32 sheet for the vertical webs out there. I've installed these three, and I'm getting ready to install the last one. The way I do it is I make up a blank and then kind of put it in there and mark it to its to the proper depth with a pen, with a pencil, and then cut it off, using the knife. So this one is already cut to the proper depth, but now it needs to be fit to go in between the two ribs. It's not absolutely necessary to get an exact fit between the two ribs, because the primary purpose of this vertical webbing is to do two things. It's to keep the spars from compressing together as the wing tries to bend, and it's also to keep the spars from moving in this direction as the wing tries to bend. So you can see that vertical grain then is best suited for both of those functions. So now we'll glue this part in, and you might notice the plastic glove I got on my left hand. I use that to keep the CA from running through the webbing and gluing my fingers to the web as I'm gluing it. You don't have to worry about that when you're using a 16th sheet, but the 32nd sheet, the glue will come through, and it'll stick your fingers to the webbing if you're not careful. Okay, so that should take care of that. And now, in order to conveniently shape the leading edge, I'm going to remove the tip from the plan. This will give you a chance to see what happens, how you get the parts that are glued down with that spray cement off the board. Now, what I've found over the time is that if you just apply a constant pressure, gently, working around the outline and the spar, you can just pull it right up. Now, if you ever get into a situation where something doesn't want to come loose, you can always use the heat gun. A heat gun will soften the spray cement, and you can then just lift the part right off. I quite frequently use the heat gun to remove the plans from the workbench. So, here we come. There it is, just about ready. Just a constant, gentle pull will cause the glue to let go. Or in this case, I'm going to coax it a little bit with the steel scale, running it underneath the trailing edge here, which seems a little bit hesitant to come loose. There it is. Well, this corner seems to be stuck down here pretty good. There, we got it. Ah, that's it. All right, now we're ready to shape the leading edge. In this case, I want to taper it so that it's thinner out here at the tip in both width and depth than it is at the root of the tip. So I'll first then start with a razor blade plane, and plane, maybe it's a little bit flimsy, so take a look with, take a little bit of a light spray with the cement and glue it down in place. Now it won't move around while I'm trying to plane and sand on it. Ah, yes, that's much better. Okay, that's pretty close to the right taper. I'll move it a little bit here. Just lift it up and move it out. Press it back down to the cement. Take the sanding block and finish up the taper on the front of the leading edge. Okay. Now we'll take the plane and start to shape the leading edge to the contour of the ribs. The reason I do this before I add the diagonal ribs between the spar and the leading edge is that when I'm using the sanding technique to bring the diagonal ribs down to the final contour, it works much better if the leading edge is already shaped to the proper contour. So we'll just keep working on this with the plane here a little bit. Get these shavings out of the way. Okay, now it's pretty close, and I can I'll finish it up with the sanding block. I think you all know how that goes. So I'll sign off here, and when I come back, we'll have this back on the board. We'll start installing the diagonal ribs, and then we'll cut the notches and put in the turbulator spars. Now I have all the diagonal ribs installed. I made the blanks quite a bit oversized, so before I start the sanding, I'll just take a knife and by eye whittle them down a little bit. Be sure you don't want to undercut them, but you can take a little bit off to get them down. If you should happen to undercut one, it's pretty easy to just glue another little strip of wood right in there using the thick CA, and then sand it down to contour. Okay, now we're ready to harden up this the leading edge of the straight ribs here, so that we can use that as a sanding reference while we're contouring the diagonal ribs. And since I really don't want to undercut these ribs, and because the curvature is a little bit greater up here than it is back here, I'm going to put a little color on them too, so I can more readily see when I'm down to the ribs. And in this case, since I plan to cover the tips with orange, I'll use orange felt pen to put a little color in there. And then when I sand it, I'll be sure to easily see when I'm down and starting to remove the color. So I'll be back after I get them sanded. I've now finished sanding the leading edge diagonal ribs to contour. I've marked the location of the turbulator spar on the tip rib. And now with the straight edge and the little tool we talked about before, we'll go through and cut the spar notches in the ribs. Now it's going to be a little hard to cut through that crust on the top of the straight ribs resulting from putting the CA on there. But if you work at it gently and slowly, it'll come right on down. And there's that one. And we'll cut one in the first diagonal rib. Notched it out. Sometimes that little piece of wood gets caught in there. You have to clean that out before you can go on to the next one. Make sure that the the straight edge stays properly located so that you get a nice straight spar. Another straight rib here where it's been hardened by the CA, but it's cutting down there. Okay, nice notch. And I'll stop the recording right here and finish up this, and we'll get the turbulator spars installed. All right, now we've got the initial notches cut. We'll trial fit the spar in there. The idea is to make sure that the spar goes down far enough so that it's flush with the top of the ribs. And if for some reason the notch cutter that I used didn't get down far enough, then, which it didn't in this case, take a little, I've got a little notch sander here, a piece of plywood with sandpaper glued on the edge of it, and just deepen those notches just a little bit to let that spar seep down in there so that it is indeed flush. Because we want a nice smooth contour on the top of the wing. Now let's try a fit again. Yeah, that feels good. Okay, so now we can go ahead and glue that in and cut the notches for the remaining turbulator spar. Now I've got the last turbulator spar installed, and I'm going to glue it in with just a touch of the thin CA. You may have noticed that I use thin CA almost exclusively in the construction of the model, and the reason for that is that a while back I discovered that I was using up about a 1-ounce bottle of the thick CA, gap filler CA, in building a model, and it occurred to me that I was essentially adding an ounce of weight to the model. So I started using the thin CA. It requires that you make a little better joints and so on, but you end up I can build 2 or 3 airplanes with the same amount with an ounce of glue in this case. So anyway, now the tip panel is finished. It's ready to come off the board for the last time, and we just again little constant pressure, bring it right up. The problem that where it doesn't want to release is not because of the spray cement, but rather because the CA is running through and gluing to the wax paper. And I've just noticed that recently in the last few packages of wax paper, and I think it may be that they've taken some of the wax off of it to make it more microwave compatible. But anyway, there's the final tip panel, and we'll next add the tip fairing, and then we'll start building the right main panel onto the tip. Now I've got the completed tip section positioned on the plan so that I can start building the main panel onto it. I thought it might be interesting for you to see how I make sure that the alignment of the tip panel is correct and is maintained. Basically what I do is I align the spar at in line with the spar on the plan for the main panel, and then I put the combination square on the line for the spar out near the tip. Then I put the spar against the combination square. That gives the alignment in this direction. And then for the dihedral angle, the correct dimension out here for the 20 degrees that I want at this joint is 4 1/8 inches. So I've made just a piece of wood 4 1/8 inches long, and I just use that as a prop. There's enough residual contact cement, spray cement, on the plan to hold that prop in place. So, and a little light spray of cement here holds the root of the tip in place. So now we're ready to start adding the material for the main panel. Before we start building that main panel, though, I thought there was something else that you might be interested in knowing. This device that I have in my hand is another tool that I made up. I call it an angle measurer. What it really is an inclinometer. It's basically just a full circle protractor which I've mounted on a piece of plywood and added a wire pointer which is running in a Teflon tubing bearing. Now the Teflon tubing is the stuff that comes with the CA adhesive, and just take a little piece of that and put it through the center of the protractor, and it makes a nice smooth bearing for the wire. What we're talking about here, though, is we want to build a little bit of twist into this right main panel. All power airplanes that turn to the right under power need a little bit of what's called wash-in or leading edge up twist in the right main panel to assure that the model does not roll over to the right under the power pattern. Now, over the years, I have observed the amount of wash-in that people call for in various designs, and it usually turns out to be somewhere in the order of 1 degree twist. So for this wing, I need to find out how much spacing do I want to put under the leading edge in order to give me that 1 degree twist. Now remember, this wing is going to be built very stiff, so we're not going to be able to do any twisting in it after the initial construction, so we have to build the twist in. Well, the twist that I want is about 1.5 degrees in this case. So it looks like, if I put the inclinometer on there, it looks like about a 3/16 shim under the corner of the leading edge right here will give me the 1.5 degree twist that I want. Now you can see I've added the trailing edge, the bottom spar, and the leading edge of the main panel. And as I put them on the board, I glued them to the tip panel using the thick CA. This is the one case where I do use thick CA, where I've got end grain going to end grain. And remember that the ends of these are beveled such that I get the proper angle, 10 degrees on this piece, 10 degrees on this piece, gives me the 20 degree angle that I need for the tip. They're also beveled to the proper angle of 5 degrees at the center break. So now I'm fitting the straight ribs, and they're a little bit long for the depth of the notches that I cut in the trailing edge, so I'll sand it off a little bit. A little bit tight on the leading edge. Okay, that's a good fit. Now I'm gluing these in as I go. I'm using a little triangle, 90 degree triangle that I made out of a piece of plywood, just to make sure that the ribs are vertical. And a little touch of thin CA on the spar and on the trailing edge. And that rib is in place. I'll go on and put in the rest of the ribs. Then there'll be some sheeting. The center panel of the wing is sheeted with 16th balsa, so I'll lay that down first, then put the ribs in here. I'll also install the 16th plywood dihedral brace at this point in time. And I'll be back and tell you what's next at that point. All right, as you can see now, I've added all the straight ribs, the bottom sheeting for the center section, the plywood diagonal or dihedral brace, and now is the time to build in the twist. I have not added any of the diagonal ribs or the vertical webbing between the spars. The wing is still pliable or twistable at this point, but if I started adding any of the other pieces, you could not later twist it. So now is the time. And the way I do that is I try to maintain this piece stuck down here and the trailing edge stuck down. So what we're going to want to do is is pull up the trailing edge, or the leading edge rather, excuse me, and the spar. There it comes. Okay, coming up nicely now. Might be a little bit difficult here because we got a lot of area stuck down. And we'll take the scale and run that under there. See if we can break it loose. Actually, it's the wax paper again that's sticking, as I mentioned before. CA glue is sticking to the wax paper, and since the wax paper is glued down to the plans, then I'm ending up trying to lift the whole piece of wax paper off the plans. Okay, I think it's pretty loose now. Yeah, there it is. Okay, the trailing edge is still stuck down, and the root rib is still stuck down, but the rest of it is pretty free. So now is the time. We put the shim under it. And that's it. Now we're ready to start putting in the diagonals and the webbing. Welcome back. We've just finished putting in the diagonal rib blanks behind the spar. I've sheeted the center section behind the spar. I'm now ready to start the sanding process, but I wanted to show you one thing that I do at this point to protect the ribs and spars and so on the tip while I'm sanding, because in the past I have inadvertently nicked and scarred up these spars. So actually all I do is put a piece of regular old masking tape right over there, and that gives just enough protection so that if I'm careful when I do the sanding, I don't end up digging in and scratching the tip panel, which is complete finished sanded at this point. One thing I've failed to mention before, and that is that when I do lay down the leading edge, it has already been beveled in order to fare in with the top of the ribs. So once I get the rear section sanded to contour, then I can go ahead and put in the diagonal ribs in the front, and it'll be ready to sand at that point. We have the right half of the wing structurally complete at this point, and we're ready to do the final sanding, shaping the leading edge and smoothing out the contour of the center section sheeting. But before I start that, there's one thing that I wanted to point out to you, and that is if you can zoom in on this, you can see that the wings spar web and the diagonal ribs are all below the level of the bottom of the wing, and that's a result of the fact that we shimmed up the leading edge. I put these down to the workbench level as I was building it purposely in order to support the wing in its twisted configuration while I was working on it, and it's also going to be useful when I'm working and sanding on the top of the wing. So we'll take care of the top of the wing, then we'll turn it over, and I'll use a long sanding block to dress the bottom of that wing off.